And now another example. I apologize, I left out an article here. Through what angle should a 1 meter diameter wheel turn to roll 50 feet? Round to the nearest hundredth of a degree. We showed with the last problem that a wheel that is rolling, the distance that the wheel moves is actually exactly equal to the arc length of that circle. So it is a problem about arc length and radius, and we are looking for angle. Quickly, we've got a 1 meter diameter, so let's right away deal with that and get it to a 0.5 meter radius. Theta is what we're trying to find. S, our arc length, is the distance that the wheel has rolled 50 feet. Now our problem here is that our units of distance do not agree. We have the radius is in meters, the arc length is in feet. So we need to either convert meters to feet or convert feet to meters. My choice is usually to go from a larger unit to a smaller unit. So I'll go from meters, which is a bigger distance, convert that down to feet, which is a shorter, a smaller distance. I'm multiplying by a conversion factor that has meters in the denominator and feet up in the numerator. And I looked one up, and this is even still an approximation, 3.28084 feet per meter. I think it's actually 2808399 maybe. So I'm careful here. I'm beginning to round a little bit early in the problem. That's usually unavoidable if we're going between units that are metric versus English or imperial or whatever you would call it, the feet, pounds, ounces, etc. units, not metric stuff. So we're starting to round a little bit. I'm just keeping several decimal places until the very end of the problem. Don't want to cut things off too soon. So about 1.64042 feet is our radius. Next, we had an equation S equals R theta. We're trying to find theta, so I'll go ahead and solve for theta. Divide R on both sides. S over R will equal theta. We've got quantities we can use. S is 50. R is 1.64042. They're both in feet, so that's good. We know those units of feet are canceling each other, but we'll end up with units that are radians. So about 30.480 radians. Getting close, but we need this in degrees, so I need to convert radians into degrees. This answer coming out of the formula is always automatically in radians. Since the question wants degrees, we've got to take it further. I want to cancel radians, so I've got radians in the denominator. Got degrees up in the numerator, so those will be the units of our answer. So I'll do the multiply 30.480 times 180 divided by pi. I'm right at the end, so I'll go ahead and round it to the nearest hundredth, and I get 1,746.38 degrees. Now we're not thrown off by a number that's this large because we know now that we're dealing with angles and circles, we can handle angles of any measure. And an angle measure this big just means that we've gone through several rotations. Each 360 degrees is one full rotation. So in this case, we've made several rotations. We've made about 4.85 rotations. Not asked for in this problem, but sometimes just interesting to see exactly what this degree measure represents. So a wheel that is a 1 meter diameter, if it's rolling 50 feet, that wheel is going to have to make almost 5 full rotations.